Welcome back to the deep dive. So we've gone through the stack of sources you sent over, and today's topic is a big one. We're diving into AI risk and opportunity management. I mean, we all know AI is revolutionary, right? It's this powerful engine for efficiency, for innovation. But, and this is the core of it, it's also challenging everything we thought we knew about corporate security, privacy, and, well, organizational stability.
It's more than a challenge. The sources you sent are framing this as a structural crisis for traditional IT governance.
A crisis.
Yeah, because they make one thing perfectly clear. AI risk isn't some separate thing you can wall off. It's an extension of the governance frameworks we already have. But organizations are struggling because these systems, they learn, they change themselves.
Right. It's not like static software that only fails when it breaks.
Exactly. With AI, you're introducing these new, evolving uncertainties.
And then that distinction, that static versus evolving risk, that's really the whole ballgame. I mean, proactively managing this isn't just about staying on the right side of the law. It's about survival. It's about maintaining digital trust.
Absolutely. If your AI system is opaque or unpredictable or, starts producing harmful outcomes, that trust just evaporates instantly.
Yeah.
And your market value goes with it.
So that's our mission for this deep dive. We're going to unpack how organizations are trying to adapt these fundamental risk management principles, the stuff they've been doing for decades, to handle the speed, the volatility, and frankly, the ethical complexity that modern AI brings to the table.
And that means looking at both the technical vulnerabilities and the massive compliance hurdles they create.
Okay, so let's unpack this. We have to start with a foundational question. Why is managing AI risk so fundamentally different from, say, traditional IT risk?
It really comes down to two words: control and context. In traditional IT, if you have a software bug, you find the line of code, you patch it, done. With AI, you have these systems that are literally designed to learn and evolve in unpredictable ways. So it becomes incredibly difficult to understand when a failure might happen or even why, because the model is essentially changing the rules on itself as it goes.
So the risk isn't just some technical defect. It's baked into the very nature of machine learning itself. The sources also really stress that risk assessment is always contextual.
Always.
You have to understand the full scope of where that AI is being applied. Is it a sensitive HR process?
Right, or a financial trading algorithm.
Or optimizing a tiny phase in a supply chain? The consequences of failure are completely different in each case.
Exactly. And to build confidence that these self-evolving systems are, trustworthy, organizations are defining these key attributes they have to demonstrate. Things like reliability, robustness, fairness, transparency, and accountability. Without those foundational pillars, confidence just erodes and adoption stalls.
Okay, here's where it gets really interesting on the technical side, especially for large language models. OWASP, the Open Worldwide Application Security Project, they've already defined a top 10 list of threats that are unique here.
And these aren't your generic network attacks.
Not at all.
They're attacks on the logic and the input-output structure of the model itself.
And the number one threat?
Nearly always prompt injection. Think of it as the modern version of an SQL injection attack. An attacker just inputs specific text prompts, sometimes they're hidden, sometimes disguised as just normal conversation, to nefariously alter the LLM's behavior.
So they can trick it into ignoring its own safety rules.
They can trick it into ignoring safety rules, revealing confidential internal prompts, or even generating malicious content. It's essentially a social engineering attack on the AI.
Using language instead of code vulnerabilities.
Precisely. And while prompt injection targets the runtime behavior, you have much deeper attacks, like data and model poisoning.
Okay, this is where the training data itself is manipulated.
Right. The food the model eats. It's where malicious actors manipulate that data to introduce vulnerabilities or biases or even backdoors into the final deployed model. And that vulnerability is now permanent until the entire model is retrained.
Which is a huge security concern. Then there's the more direct risk of sensitive information disclosure.
Yes, where PII or proprietary info just gets exposed because the model was trained on it, or maybe it was provided during a query and the model just regurgitates it.
And we can't forget the financial risks that appear on the technical side. The sources pointed to unbounded consumption.
Oh, that's a big one. If an LLM isn't properly guarded, it can be manipulated to run an excessive number of queries. This can lead to astronomical cloud compute bills. It effectively turns a simple query into a denial of service attack on the organization's wallet.
It just shows how intertwined financial and technical security have become.
Completely.
So this whole shifting landscape where traditional defenses just aren't enough, It's obviously forced a reaction, and we're seeing two massive frameworks emerging globally to deal with this.
Right. And they represent two very different philosophies. You've got the regulatory mandate versus voluntary best practices.
Let's start with the mandate, the regulatory hammer, so to speak.
That would be the EU AI Act. It's a legally binding, risk-based framework. It classifies AI systems into 4 very explicit categories, and that category dictates everything: the oversight, the documentation, the compliance requirements.
And that tiered approach is where the real regulatory power lies. At the top, you've got unacceptable risk.
Prohibited, banned outright. These are systems that manipulate behavior or violate fundamental rights. Think social scoring systems.
Gone, and you get to the really high-stakes stuff, high-risk system.
Exactly. This is where you find critical applications.
Yeah.
Healthcare diagnostics, law enforcement, border control.
Critical infrastructure.
Right. These require incredibly stringent oversight, extensive documentation, and external conformity assessments before they can even be deployed.
And below that,
You have limited risk systems, like a general-purpose chatbot. There, the main requirement is just transparency. You have to tell the user they're talking to an AI. And then finally, low or no risk systems, like a simple spam filter, which have very little regulatory overhead.
But the key strategic point here, especially for anyone listening outside the EU, is that this act applies extraterritorially.
It does. If your AI system, built anywhere in the world, impacts EU citizens, your organization has to comply with these rules. It's setting a global standard, whether you like it or not.
Okay, so let's contrast that with the other major player, the NIST AI Risk Management Framework, the RMF from the US. If the EU Act is the compliance checklist, what's the NIST RMF?
It's the methodology blueprint. It's a voluntary guide. It provides best practices and a structured methodology, but without the legal enforcement or the rigid classifications. It establishes 4 core functions: govern, map, measure, and manage.
Now, our listeners are familiar with what governance means in a traditional sense. How does AI change the game for those 4 steps?
It forces continuous adaptation. Govern isn't just about setting a policy and walking away. It's about setting a policy that anticipates how the machine will evolve. Map requires you to identify not just inputs and outputs, but where the model might drift from what you intended. Measure means developing new metrics for things like inference-based privacy risk. And manage means having real-time response plans for when that model's performance degrades unpredictably.
That makes a lot of sense. So the EU Act is the what you must comply with, and NIST is the how you build a flexible structure to do it. But if NIST is voluntary, why would a company, say, outside the EU, bother with all that governance overhead?
It's a fair question. They bother because the cost of not governing is catastrophic. Even without a direct legal mandate, you've got market pressure, insurance requirements, and just the sheer financial liability of a public AI failure. Think about a major bias scandal. NIST RMF offers a standard defensible path to achieving that trust no matter where you are.
Okay, so with the frameworks established, let's look at how organizations are actually translating this into cold, hard risk management, classification, assessment, and response.
Right, so we talked about the EU Act's classifications: unacceptable, high, limited. Those are qualitative. They describe the type of harm, but to really get the attention of senior leadership and prioritize your spending, you need quantitative data.
And that's the big strategic shift. You can tell the board, we have high risk, and they'll nod. But if you tell them, we have $20 million in quantifiable exposure, you get their immediate attention.
That's exactly where the fair error approach comes in.
A fair error.
Yeah, it translates AI-related risk into financial terms. It takes it out of the purely technical domain and quantifies the potential loss from a specific AI failure scenario. By using monetary terms, you elevate AI risk from just an IT problem to a capital expenditure conversation. That's why it's so critical.
So once that risk is quantified, or if a system is just deemed high risk by the rules, then the mandatory assessments kick in. And the sources highlight 2 assessments that are really focused on impact.
Yes. For high-risk systems under the EU framework, the Fundamental Rights Impact Assessment, or FRIA, is required before deployment. The FRIA forces an organization to ensure the system doesn't negatively affect fundamental human rights, privacy, data protection, equality. It makes you preemptively design mitigation plans and assign human-in-the-loop or HITL requirements for those critical decisions.
And the traditional privacy impact assessment, the PIA, that also has to evolve pretty dramatically for AI. I mean, traditional PIAs were mostly worried about data breaches. This is a whole different beast.
The threats are systemic now. An AI-focused PIA has to include things like algorithmic bias, but even more critically, inference-based privacy risk. This is where the AI can deduce incredibly sensitive details about people that were never explicitly provided.
How so?
Well, if your AI recognizes specific patterns of behavior, it might infer a protected health status or a political affiliation. You get severe privacy violations even without a data breach.
And these assessments then guide the final step, the risk response strategy. So what does this all mean for day-to-day decisions? Let's walk through the 4 common strategies in an AI context.
Okay, let's start with accept. This is when the cost to mitigate the risk outweighs the potential loss, so you just monitor it. A good example is a financial institution accepting a 5% false positive rate in its AI fraud detection. The millions it saves from correct detections makes that residual risk acceptable.
Then you have avoid. In AI, this can be a really difficult but sometimes necessary business decision. It means deciding not to deploy the tool at all.
And we see this a lot with AI-driven hiring systems. The potential for automated discrimination is so high, and the legal and reputational risk is so massive, many firms just choose to avoid them entirely.
Makes sense. The most common one is probably mitigate.
Right, reducing the probability or the impact of the risk. So if your algorithm is, say, disproportionately denying loan approvals for a certain group, mitigation means you refine the training data, re-engineer the model,
Or you add a mandatory human in the loop for certain decisions.
Exactly, for all the outlying decisions. And finally, you have transfer or share. This is usually about moving the financial impact to a third party, like through an insurance policy or a contractual agreement. A car manufacturer might transfer liability for AI-driven car accidents to insurers.
Okay, now I want to dive back into the technical weeds because some of the most sophisticated attacks go way beyond just prompting an LLM. They target the fundamental integrity of the model itself.
Yes, we should expand on data poisoning. This is highly complex, often malicious. Bad actors will insert false data into these enormous training data sets, sometimes with the goal of creating a hidden vulnerability or a backdoor that only they know how to trigger.
So it compromises the model at birth.
That's a good way to put it. And once that model is trained and deployed, it becomes a valuable asset, and people will try to steal it.
Which is where model theft or extraction comes in.
Exactly. If an attacker can't get to your servers, they can try to reverse engineer your investment. They do it by sending thousands of crafted inputs and just meticulously analyzing the outputs until they can reconstruct a high-quality functional copy of your million-dollar algorithm.
That's a massive IP risk right there.
It is. And related to that is model inversion. So with this one, instead of stealing the whole model, the attacker is trying to deduce sensitive information about the original training data. It's like looking at a finished cake and being able to figure out the exact brand of flour that was used.
And if that cake was made with, say, proprietary medical records, that inversion attack could expose private patient data, which circles us right back to compliance and privacy.
Precisely. And we have to talk about hallucination attacks. This is where a model produces information that is false or misleading, but sounds completely credible. This isn't just a technical glitch, it's a massive non-technical threat. It creates organizational risk through misinformation, reputational damage,
And legal liability if a business decision is made based on that false output. That brings us to this whole extensive list of non-technical threats, the risks that ethical concerns introduce, which you can't just patch with a security update.
Right, and the sources really emphasize that beyond bias amplification and litigation, there are major financial risks. The cost of compute for training these massive models is skyrocketing. That's a huge capital and operating expenditure. And this also introduces environmental concerns, right? The high energy and water demand for these huge data centers.
Then you have the minefield of legal risk, especially around intellectual property. With generative AI, the outputs might unknowingly pull in copyrighted material from these vast, often unvetted training data sets. And the organization deploying that AI, the user, could face serious legal liability for IP infringement.
Which leads us directly to the complexity of the AI supply chain, the shared responsibility model. The key is to understand the distinction between the two main parties.
Okay, first up, the AI provider, the vendor who built the system.
They're responsible for the quality, the security, and the inherent risk of the AI system itself. They have to perform those crucial conformity assessments for high-risk systems before they're ever sold.
And second, the AI deployer, The user, the subscriber, the company operating the system.
Their responsibility is the safe and ethical use of that AI within their specific environment. That means they have to conduct internal audits, control the data they feed the model, and make sure they have qualified people assigned for that human-in-the-loop oversight.
And this shared model, it also creates huge business challenges. I'm thinking of vendor lock-in. If you build your entire business process around one proprietary AI model, switching vendors becomes prohibitively expensive. It just underscores why getting contractual clarity on things like IP ownership is absolutely non-negotiable before you sign anything.
It has to be part of the initial conversation.
What a deep dive. We've gone from defining the fundamental nature of AI trust all the way to navigating these highly specific attacks like model inversion. And we've covered the complex legal and operational responsibilities in the supply chain. I think the clear directive from all the sources is that organizations have to integrate these AI-specific assessments, the FRIA, the adapted PIAs, into their existing enterprise governance structures. Because AI risk is enterprise risk. It affects the bottom line, the legal department, the core operational integrity of the whole company.
And this raises, I think, a really important question for everyone to consider. Given this unique array of non-technical threats, from financial exposure due to compute costs to the reputational damage from an unforeseen failure, is it really possible for organizations to fully manage AI risk using only traditional technical controls and audits? Or will the long-term sustainability of AI rely entirely on establishing and contractually enforcing human-centric ethical standards and regulatory guardrails?
It feels like the balancing act of the decade, doesn't it? Maximizing the incredible gains of AI while at the same time maintaining robust human oversight and rigorous compliance at every single step. Thank you for diving deep with us today.